Now in this video we will see that what is a definite integral and see few properties of definite integrals. Now if f is continuous in the cluster interval AB and capital F of x is any antiderivative of f of x, that is f dash of x is equal to f of x, then integral a to b small f of x dx is equal to capital F of b minus capital F of a. Now this is the second fundamental theorem of integral calculus. Now to see the what is exactly this definite integral, we'll have this example. Suppose we are asked to evaluate integral 2 to 5 x square dx. Then by having our capital F of x as x cubed by 3, by this we have capital F of 5 minus f of 2 to be the given integral, and replacing x by 5 and 2 we have this step, and evaluating that further, or rather simplifying it further, we get integral 2 to 5 x square dx to be 39. Now the concept of definite integrals is useful in finding the arc length, area, volume, density, etc. Now we will see few properties of definite integrals. First one, integral a to b f of x dx is minus integral b to a f of x dx. You can see that the limits are interchanged. So that is the first property. When you interchange the limits, you will have negative sign. So that is the first property that we are going to see. And then the second one, integral a to b f of x dx is whenever we have c coming between a and b, this can be rewritten as integral a to c f of x dx plus integral c to b f of x dx. And the third one, integral a to b f of x dx is integral a to b f of t dt. That is, this is only a dummy variable, the variable of integration. It can be replaced by either t or u or v or y or z and so on. And the fourth one, we have two subdivisions. In the first subdivision we have integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. And the second one, it's a particular case of this. Just by taking a as 0 and b as a, we will get this. That is integral0 to a f of x dx is integral 0 to a f of a minus x dx. In very many problems we'll be using this property. And the fifth one is integral minus a to a f of x dx. Its value will be twice integral 0 to a f of x dx if f of x is even, and if f of x happens to be an odd function, then this integral value will be just 0. Then the last one, integral 0 to 2a f of x dx is twice integral 0 to a f of x dx if f of 2a minus x is f of x, and it is 0 if f of 2a minus x is minus f of x. So whenever we make use of this property, we'll have to check whether this one is satisfied. If this is satisfied, the value will be twice integral 0 to a. It looks as though that this 2 jumps from there, from the upper limit, it jumps down, provided you have this net. Imagine that somebody, for recording sake, somebody falls from the top of a tall building. If there is, say that a hero is jumping, then if there is a net, something like this is the net. If this net is there, then this 2, who is the hero here, can jump nicely. If the net is not there, imagine that this is the net, this net is not there, something else is there. In that case, then this hero will become 0. So you have the sixth property, can be used provided this one, remember this net should be there, only then this two will jump here. Okay, so that these are the 6 properties that we are going to prove now. First one, integral a to b f of x dx is minus integral b to a. That is, you can interchange, whenever you interchange the limits, then here there will be a change in sign. We shall take integral f of x dx to be without the limits. We shall take that as capital F of x. Then if you consider the LHS, integral a to b f of x dx will be capital F of x between a and b, that is f of b upper limit first and then the lower limit, f of b minus f of a, name that as equation 1. And then we'll consider the RHS which is minus integral b to a f of x dx. This we have already taken as capital F of x. So with the negative sign, capital F of x between b and a. So when we substitute the upper limit, we have f of a. When we substitute the lower limit, it is f of b. So you have minus of f of a minus f of b. That will give you capital F of b minus f of a. So if we name that as equation 2, from 1 and 2 it is obvious that integral a to b LHS equals RHS, that is integral a to b f of x dx is minus integral b to a f of x dx. Now this says that in interchange of the limits of integration only changes the sign of the integral. Now second property, integral a to b f of x dx is integral a to c and then c to b. A to c f of x dx plus c to b f of x dx. So we'll consider integral f of x dx as capital F of x, so that the LHS will now be integral a to b f of x dx is equal to capital F of b minus capital F of a, name that as 1. Then we will consider the RHS, which is, because this one is taken as capital F of x, between the limits c and a and c, upper limit is c, so f of c minus lower limit a, so minus f of a. And the same way here, f of b, lower limit is c, so minus f of c. So we can cancel these two f of c here with the negative sign, leaving f of b minus f of a. So if we name this as equation 2, then from the equations 1 and 2 we have LHS to be equal to RHS. So whenever I have a number lying between these two, I can always introduce that here, so that the integral can be rewritten in this way. Next we have property 3, integral a to b f of x dx is integral a to b f of z dz. That is, the value of the definite integral is independent of the choice of variable of integration. This is called the variable of integration. So in any integral we have this to be, this is called variable of integration, this is called variable of integration. And the whole lot is called integrand. And of course this is lower limit and this is upper limit. So this is capital F of, this f of x is called integrand, x is called variable of integration, f of x is called integrand, x is called variable of integration, and this one is lower limit, this one is upper limit. Now the proof goes like this. We shall take f of x to be capital F of x as before, and then this one, the right side with z we have, so that we shall take as capital F of z. Then when you consider LHS, it is this integral a to b f of x dx is capital F of x between the limits a and b, so you have f of b minus f of a. and RHS in the same way between f of z between a and b. So you have f of b minus f of a. So if you name this as equation 1 and this is 2, then from 1 and 2 we have this. So the value of a definite integral remains, the value of the definite integral remains unchanged if the variable is changed, provided the function and limits of integration remain the same. When you change it, then instead of a, b, you have say c and d, whether they will be equal? No. So the limits of integration should be the same and the integrand f of x should be the same. So in that case, then we will have this. It's only a dummy variable. Now the fourth one, we have two subdivisions. First one, integral a to b f of x dx is integral a to b. Just add these two up. So a plus b minus x dx, and the second one, a particular case of this, integral 0 to a f of x dx is integral 0 to a f of a minus x dx. Now we shall take this a plus b minus x as some z, so that dx will be minus dx will be dz, or dx will be minus dz, and f of a plus b minus x will be f of z. Now we consider the RHS. So that will be, you have, see, when you substitute the limit, you are substituting for x the lower limit a. So when x takes the value a, you have a plus b minus a. So you can cancel these two out. So your z will take the lower limit as b correspondingly. We are replacing this dx by minus dz. So minus sign is here, dz we have, and for this you are replacing it by z. The limit should also be changed. So when x takes the value, this is how we read, x takes the value a means what will z be? Z will take the value b. And when x takes the value b, suppose I have this to be say b, then we have we can cancel these two, so that z will be this. So we have z to be, z taking the value a whenever x takes the value b. So this is what we have. Now using P1, this is what P1 is. You can, when you have minus sign, you can interchange the limits. So here minus b to a, here plus a to b, and make use of P3, which is, you can replace, this is only dummy variable, so z, so you have f of x dx. So that is using P1 and P3. Here remember, whether I have t or u or v, that doesn't matter. So even f of z dz. So we have using the third property, we have this. So but this is nothing but your LHS what is given. Now the second one, if you proceed in the same way, then this is what we have. A minus x should be taken as z. So the dx will be minus dz, and f of a minus x naturally will be f of z. And we have the limits. When x takes the value a, when x takes the value a here, your z will take the value 0. And then when x takes the value 0, your z will take the value a. So for the lower limit 0, we have a, and for the upper limit a, we have 0. So we have this. So again using P1 and P3, P1 is this, P3 is this. So where is P1 used? In rewriting this as this, we have, actually if you want we can have one more step, that is integral 0 to a f of z dz. So this is by using P1. And then when you use P3, it is only dummy variable, so you have this step. So that is your LHS. Now the same problem can be dealt by just using first subdivision by taking a as 0 and b as a. Now next property, whenever f of x is even function, by even function we mean this: a function f of x is said to be an even function if f of minus x, if f of minus x is equal to f of x. Like in the case of say x square plus 2, if we consider this is my function x, say this is even because your f of minus x is minus x the whole square plus 2, so you have x square plus 2, you are getting back the equation, the function. So in such case we call that to be even function. On the other hand, if we consider say x cube, just f of x to be say x cube, then f of minus x will give us minus x the whole cube, which is minus of x cube, which is minus f of x. So in this case it is called an odd function. This is odd, and in this case it is called even function. So whenever f of x is even, we know pretty well that our sine function is odd and the cosine function is even. So integral minus a to a minus a to a f of x dx is twice integral 0 to a f of x dx if f of x is even, and 0 if f of x is odd. Now in the first case we shall take f of x to be even, which means f of minus x should be equal to f of x. So that is the definition that we have. F of minus x should be equal to f of x, and for odd it should be the sign will come out, this minus sign will come out, that is for odd function. So in first case only we consider, so f of minus x is equal to f of x. Name that is statement Q. Now we shall consider the LHS, which is integral minus a to a f of x dx. We can rewrite that as, this is by using P2. Whenever we have a number lying between a and b, it can always be introduced. So you have 0, when we consider this x-axis, summate here minus a and here a, say. So between minus a and a we have to have, so what we do is minus a to 0 and then 0 to a. So we have minus a to 0 and then 0 to a. So we have integral 0 to so integral minus a to a f of x dx is minus a to 0 f of x dx plus 0 to a f of x dx. We shall name this first integral as say I, the second one as j. Now we will consider I, which is minus a to 0 f of x dx. Now replace your f of x by f of minus x, because it is an even function. So you have minus. Why this minus sign comes? Because you are replacing x by minus y. You are replacing x by minus y, so that dx will be equal to minus dy, dx will be equal to minus dy. So that is why you get minus sign here, and f of minus y. When x takes the value, minus a, when x takes the value minus a, your y will be a. So your y will be taking the value a. When it is 0, x is 0 means y is also 0. So this is what we get. Now f of minus y is even function, so f of y dy that you have. The minus sign and then a to 0 we have. So it can be rewritten as using P1. P1 is what? Integral a to b f of x dx is minus integral b to a f of x dx. So we make use of that. So you have this, and then of course this is only dummy variable, so we can even say that we have used p3 also. So this is what we have, integral 0 to a f of x dx. So this is the first I alone that we have considered. Already j is again the same. So we have LHS to be 2 times integral 0 to a f of x dx, because f of x is even. When f of x is odd, you will have the same thing but with the negative sign. So one will be with the positive sign, the other one will be with the negative sign for odd function. So they get cancelled, giving you 0. And the procedure is the same. You consider minus a to 0, you put x as minus y, and then make use of this R, statement R, because it is odd, you have this. And then you have make use of P1, so that you get this. So this is only I. J is also there. J is also there, but it is, one is with the minus sign, the other one is with the plus sign. So they get cancelled, giving 0. So when it is even twice, you can write. When it is odd, it is just 0. Now the next one, integral 0 to 2a f of x dx. Remember that this is the net to be remembered. This net, only then this hero 2, we shall imagine this to be our hero 2. So he can jump provided this net is there. Like you have from a tall building, this man is jumping, is 2 say, and we have net here. That net is your f of 2a minus x is equal to f of x. So when he jumps down, you will have 2 times integral 0 to a f of x dx. So when the same person is jumping, can he jump? When he jumps, if this is not there, then what will happen? He will not be there. So he becomes 0. So you can remember in that way. You have f of 2a minus x is f of x. If this is true only, you can have this 2 jumping down. Otherwise, if it is with the negative sign, means you have that to be 0. See, actually this one is there, net is there, but this net is, say something like you have a hole, big hole, and through that he falls down only. So that hole we can have, because net is not there, we cannot say net is with some defect is there. So f of 2a minus x is equal to with the minus sign f of x. So there is something wrong in that, so he falls down and it becomes 0. So condition is to be remembered to make use of this property. We shall take f of 2a minus x to be, say, some f of x. I mean, not some f of x. This is from the condition that we have. Now we shall consider our LHS, which is integral 0 to 2a f of x dx. We can split and write. It is something like this that you have, that I have 0 here, somewhere here a, and then here 2a. So I can have from 0 to a and then from a to 2a. 0 to a to 2a. 0 to a to 2a. F of x dx using this property that we have. Now this is named as I and this is named as j. So now we shall consider the second integral. This is the second integral, and that is taken as j. So integral a to 2a, integral a to 2a f of x, integral a to 2a f of x dx. This integral a to 2a, f of x is replaced from here. From here it is replaced as f of 2a minus x, and we make use of this q, so that 2a minus x, we can replace it by say some f of y, later dummy variable, so you can have it as f of x dx. So we have actually here itself we can have f of x dx. So 2a minus x, when we consider 2a minus x as say y, if we are taking like this, f of 2a, 2a minus x is taken as y, then in that case minus dx will be equal to dy. So we can retain this as such, so that this minus sign we can account for, minus y dy. And when x takes the value, a, 2a minus a, that will give you a. So your y takes the value, a. And then when x takes the value 2a, you get 0. So integral a to 0 f of y dy. And you can make use of property 1, and you have integral 0 to a f of x dx, and that is your LHS. So here this one is there already, this is not the case. Twice integral 0 to a f of x dx is because we have evaluated only this, and it came out to be integral 0 to a f of x dx. And already, remember, I is there with the same value, so twice that you get. Now when we consider f of 2a minus x as minus f of x, it's a wrong net. Net is there, but it is not correct, wrong net. So integral a to 2a f of x dx, when we consider, you have integral, you're replacing that with the negative sign. F of x is here. Minus integral a to 2a f of 2a minus x dx. When you replace 2a minus x by y, you get f of y, and here you will have already one minus sign is there. And because of this, dx is equal to minus dy. Because of this minus sign, you have here plus sign. Okay, so integral, again the lower limit is a, upper limit is 0, f of y dy. So again, if we change the limits by p1, so you are using p1, so you have minus sign. So the second one, in this case I plus j, the first one is with the plus sign, the second one same thing only we have, but with the negative sign. So this is with the plus and this is with the minus, so we get 0. So when a wrong net is placed, we get 0, but when correct net is placed, we get 2 times 0 to f of x dx. So in the upcoming video, we will see few problems and definite integrals.